The resistivity of a metallic conductor is approximately given by rho T is equal to rho naught into 1 plus alpha of T minus T naught. So transmission loss is nothing but the power loss in the transmission cables because of their resistance, and this loss in the cables is called as transmission loss. This graph shows the temperature increases with increase in resistivity. Hello everyone, welcome to session 3 of chapter 3 Current Electricity. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, in the last session we have learnt about Ohm's law, resistance, conductance, resistivity and conductivity and many more interesting concepts. In today's session, let us begin with what are the effects of temperature on resistivity of metals. So, the resistivity value is different for different materials. What is this effect of temperature on resistivity of metals? Let us understand. So, when the temperature of metallic conductor increases, its resistivity also increases. The resistivity is depend on temperature in case of metals. The resistivity of a metallic conductor is approximately given by rho T is equal to rho naught into 1 plus alpha of T minus T naught. Let us now understand what are the terms related to this expression, where rho T is the resistivity of a material at temperature T, rho naught is resistivity of a material at temperature T naught, and alpha is temperature coefficient of resistivity of a material. By knowing the values of T, T naught and alpha, we can find the resistivity of a material at temperature T. Now let us understand the graphical representation of variation of resistivity of materials with respect to temperature. Here we have a graph for the variation of resistivity of nichrome, manganese and constantan materials. You can observe here along y-axis we have to vary resistivity and along x-axis we are varying temperature. Now you can observe this graph shows the temperature increases with increase in resistivity. It is linear increase in resistivity in increasing the temperature. Say for example, if you consider copper, then how does its resistivity vary with temperature? So the temperature, as the temperature increases, the resistivity of the copper will also increase. The materials like nichrome, manganese and constantan, and this is for copper. So let us now understand how does this resistivity vary with temperature graphically for semiconductors. So you can observe here the resistivity of a semiconductor, it is decreasing as the temperature increases. So the resistivity of semiconductor is inversely proportional to temperature. As the temperature increases, its resistivity decreases. So let us now understand another important topic, that is electrical power. So what is electrical power? What is the expression for electrical power? So let us derive the expression now, then we will define what is electric power. So let us derive an expression for power loss in a conductor of resistance R carrying a current I at a potential difference V. Now we have considered a conductor with endpoints A and B, in which I is a current flowing through it and it is provided with a potential of V across the ends A and B. So this is a conductor with ends A and B. It is provided with a potential difference across its ends, that is V, and I be the current flowing through the conductor. Now let us define. Here is the diagram. The A is one point and B is another point. The potential at this point is V of A. Potential at this point is V of B. So electric potential at A is V of A and electric potential at B is V of B. The current flowing is from A to B. We all know that the conventional current direction, it is from positive side. Since the current is flowing from A to B, we can write potential at A is greater than the potential at B. That is V of A is greater than V of B. The potential difference across the 2 points AB is given by V, that is the potential difference. It can be calculated as taking the difference between the potentials at both the points, that is VA minus VB. Now, in a particular time interval delta T, the amount of charge flowing through the ends A and the end B is given by delta Q is equal to I into delta T, because we know that the current flowing through a conductor can be calculated as rate of flow of charges, that is I is equal to Q divided by T. but we are now writing an expression for amount of charge flowing from one point to another point, that is Q. So from this we can write Q is equal to I into T. So we can write delta Q is the amount of charges from the point A to B and I is the current, delta T is the small time interval. Now the potential energy of charge at A is VA into delta Q. Why it is VA into delta Q? Because we know the potential energy U is equal to Q into V. We know the expression for potential energy is U is equal to Q into V. Here the Q is delta Q and V is the potential at one particular end, that is V of A. Similarly, the potential at another end, that is B, which is given by VB into delta Q. Now, we know what is potential at A and what is potential at B. Let us now find the change in potential energy. The change in potential energy can be calculated as final potential energy minus initial potential energy. So, initial potential energy is at A, final is at B. So, we can substitute final potential energy is VB into delta Q minus initial potential energy is VA into delta Q. So, we can take delta Q common in both these expressions and we can write V of B minus V of A. We know the potential difference V is equal to VA minus VB. But here we have VB minus VA and hence we can take negative V. So we get minus IV into delta T. How did we get this expression? We know I is equal to delta Q divided by delta T. From this we can write delta Q is equal to I into delta T and hence the above expression becomes delta U is equal to minus IV into delta T. Here what is the significance of negative sign? Negative sign is because of decrease in potential energy. But what is the significance of this decrease in potential energy? The decrease in potential energy of charges is equal to increase in their kinetic energy according to law of conservation of energy. That is delta K is equal to minus delta U, which means increase in potential energy is equal to decrease in its kinetic energy. So delta K is equal to what is delta U? We have derived in the previous slide, that is minus IV delta T. Substituting the same, we get IV delta T, which is greater than 0. In an actual conductor, the amount of energy dissipated as heat during the time interval delta T and it is given by delta W is equal to VI into delta T. So this dissipated power is equal to the energy dissipated per unit time, that is P is equal to delta W divided by delta T. What is this delta W? That is the energy dissipated per unit time. So that is nothing but power dissipation. So delta W is nothing but VI into delta T. We are substituting the terms of delta W in the above expression and we get P is equal to VI delta T divided by delta T. These two gets cancelled and we remain with P is equal to V into I. So the power, electrical power is nothing but the product of the potential and the current, V into I. So by using Ohm's law, we know V is equal to IR or V is equal to R into I. Now let us substitute the same in the above expression. P is equal to, in the place of V, I can substitute I into R. So what do we get? P is equal to I into R into I. So I into I is I square into R. But what is I? I is equal to V divided by R according to Ohm's law. Now we have I square here. So I is nothing but V by R. So we can write it as V square divided by R square. That is P is equal to V square divided by R square into R I have in the numerator. One R and the other R in the denominator gets cancelled and we remain with P is equal to V square divided by R. So this is called as the power loss or we also call it as ohmic loss. So now let us understand what is the meaning of transmission loss. So the power loss in the transmission cables because of their resistance and this kind of loss is called as transmission loss. How to reduce this transmission loss? The power dissipated in the transmission cable of resistance is given by P is equal to I square R. But now we have to write the expression for I. How to write? We know P is equal to V into I and from this we can write I is equal to P by V. But what is this P? What is this V? What is this I? We have considered P be the power that has to be delivered to a device of resistance R which is having the potential difference V and I be the current passing through it. Then we know P is equal to V into I and from this we can write I is equal to P divided by V. So this is my equation 1 and this is my equation 2. Let us now substitute the value of I in the above expression and we get P is equal to I square R we have, but I is nothing but P divided by V and we get P square by V square into R. We can also write it as RC, that is resistance in the cable. So from this expression, what can we conclude? We can conclude that to reduce the power loss, we have to increase the voltage, or the transmission cables must be carrying a high voltage. If voltage is more, power loss will be less. So here we can say P and V are inversely proportional to each other. To reduce the power loss, the V value must be very high. This is all about the power in an electrical conductor, the power loss and transmission loss in cables, and what are the measures that has to be followed to reduce the power loss. In the next session, let us learn some more interesting concepts. Until then, keep learning all of you. See you all in the next session. Thank you.